All right, this is where we left off last time. And I don't know why this is emphasized. It shouldn't be. That's just a mistake. But last time we were talking about the magic method, that double underscore method, EQ, which is how we define equality for the objects that we're defining, right? So this is where we say, what does it mean for two spheres to be equal? Because when you make a sphere, Python doesn't know what it means for two spheres to be equal. We need to tell it, right? We are defining equality for those spheres. And the big trick here, like, we define it however we want it, right? We can say whatever we want. Now, what it matters for our needs really depends on our needs. What I'm saying here is, well, just check if the x's are equal, the y's are equal, the z's are equal, and the radii are equal. Then, if they are, we'll call them equal. Now, for your needs, you might not even maybe care if the two, where they are, doesn't even need to be equal. Maybe all that really matters for equality for your particular program is just that the radius are the same. So maybe you don't even care about the x, y, z. But you get to say. And then we had that one little catch where, well, look, and there's a lot of ways we can go about doing this. If it's an instance of a sphere, so if other is a sphere, check. If they're not, just they're not equal. A sphere is not equal to a string. I don't need to look any deeper than look at their types. So that's what this is checking here. It's that special function is instance that will tell you is other, or return a Boolean. So that's where we define equality. And we said we could go back and we should do this for a circle. If we go back to our circle class that we wrote in the previous topic, equality for a circle might look something like this. If their radius values are the same, they're equal, but of course, only bother checking if they're not. And it's important to check their type before doing this, because if other is, let's say other is a string, for example, and you say, well, what's other.radius? Strings don't have an attribute radius, so the program will crash. You don't want your program to crash if they're not equal. You want it to say false. So just check first, that's why. Questions about that? And then we did kind of cover this inadvertently in lab. It wasn't part of the labs, but I showed you because it made it a little easier. Sometimes, like if you print out an instance of your object, it usually, by default, just says like class name at OX blah, 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 right? Oh, also, don't let me walk too far. The mic is charging, so what I just did was bad. It gives you something that looks, yeah, like this, right? If I made a sphere and printed it out, it would say like, oh, sphere object at whatever. That's great and all. It tells you something, I guess, but chances are it's not that helpful for your needs. This is the default behavior. Just like how like EQ had default behavior, and the default behavior for EQ was, are they literally the same object? And then we overrode it to mean what we need it to mean. So we basically redefined the EQ, because whether we write it or not, Python sneaks one in for you. You'll just never see it. So we override it. The same thing with the repr was what we're learning about right now. What does it mean? Like, what should your object look like if you ever printed it out? What should its representation be? By default, it's that. But again, probably not that helpful for your needs. So often what we do is we say, okay, no, for what I want this to be, I want it to look a certain way. And you can think of the list, for example. If I were to print this out, right, if I had some list and whatever I did something to it and I printed it out, we get a nice looking list, right? What does it look like? Well, it's got an open bracket, the contents, and then a closed bracket, right? That's what it looks like. Because someone wrote the code for the list class that says if someone prints out the list, that's how you look. But as it stands, no one wrote the code for what a sphere should look like. So it just does that. So what we want to do is we override this magic method to say, no. If anyone wants to like print out an instance of the sphere class, look like this. That's where we define it. And we do that with the repr. Okay? Yeah. And this is an example of what one might do for an object like this. Now, with the list, people had in mind, like, okay, what should a list look like? We'll have it formatted like a list. Yeah, that's great, right? Now, what should the sphere look like? Well, I mean, we can make it look like whatever we want. We could try to like draw a picture of a circle or something, I don't know. But not great. So often we want to print things out for like maybe debugging purposes. Like, okay, what is this sphere? Like, I made this sphere. What is it? And then you print it out and you can be like, oh, it's a sphere that has the attributes I want, right? That it should. In the same way that if you're debugging and you've got some variable x and it should be an integer and you're like, well, what is it? Print out x? Oh, it's 17. Good, right? Same idea with a sphere. But if all you're seeing from a sphere is something like this, not that helpful. So we want the sphere the representation of the sphere to be meaningful to me, the programmer, right? We want it to tell us something, right? And sometimes I don't really have a particular like format in mind, like the list, how I want the brackets followed by everything close bracket. Sometimes I just want to print out the sphere and some of its like attributes. So whenever you don't really have anything in mind, a very common pattern is this. Effectively, it's name of the class, open parenthesis, followed by the attributes, close parenthesis. Sometimes you'll see it where they're labeled, like x equals 1, y equals 2, z equals 3, radius is 4, assuming that I created a sphere with an x, y, z, and a radius of those values. Sometimes you'll see it with the attributes labeled. Sometimes you don't. It doesn't really matter. Whatever you like. But this is how you would write it. You would write it some way like this. Your repr, right? Now, note, it must return a string. Often, one of the most common mistakes new programmers make is they'll make repr print this out. No, this should not print anything. All it does is return a string. That's what it does. So, what is it? Well, I've got a fancy f string here to make it nice. Sphere, open parenthesis, attribute with its value, y with its value, z with its value, radius with its value. And if I were to copy this over, just for demonstration purposes, it wouldn't be crazy. Like, it is not uncommon to see them unlabeled. This is a common format too where you don't label them. But the point is, there's just some standard, well, if you want to print it out, you make it look like this if you don't have anything else in mind. So here, if I printed out that same sphere, it would say sphere 1, 2, 3, 4. That's what it would look like. Then, well here, I'm going to go get the whole sphere class. Let me copy it over. Actually, I don't really need the whole class. I'll just create with the constructor. Yeah. Whoa. Whoa. I don't need math for this. There. Okay. So here, I'm just making the class. All it's doing right now, like this is a simplified version of what we already saw, right? The other one we had included all those other methods. I don't need them for what I'm about to show you. So that's why I'm not including them. So here, let me comment this out. So I go down here, and I create a my equals sphere 1, 2, 3, 4. Print my sphere. That's what we see, right? That's the default behavior. But if I go here, rerun it. Now we define what the repr is. We overwrite the existing one that you never see. And we print it out there. Looks like that. Great. Right? Now this is a lot more meaningful. Now I'm like, what's that sphere? Oh, that's what that sphere is. Okay? If you wanted, you could try to like render it, I don't know, but don't. That'd be way too much work. And to show you what I mean here with the difference, if I go down here, there. Now, okay, great. Now it's just formatted with the labels of each attribute. Cool. Notice, did I call this method directly? No. I never called that method directly. I printed it out, and when you print it out, it'll automatically go and call this to print it out. Neat, eh? There's also another magic method called str, which is very similar, but I'm not going to get into the weeds of that one. Yes?
So I'm kind of confused about when repr gets called. It's called whenever you print out the object.
Well, it gets called, so here's actually what is happening. Equals str of my. So this is actually when it gets called. So I'm just skipping a step here. So if I ever wanted to make the string version of my object, it calls the repr. Okay? So there, right? Now you're saying, well, you never did that when you just called print. Right? So like what's going on there? How, you never called it. Well, actually, in order to print anything out, Python needs a string. Okay? Like when you print out the integer 7, it's not actually printing out the integer 7. Because what is the integer 7? The integer 7 is just a number. It's not the symbol. So when you want to print out the number 7, the value 7, Python goes, okay, well, turn it into a string, print it out. Turn it into the actual corresponding symbol. So whether you like it or not, print just calls the string. Like if you were to open up print, it would be converting it to a string, whether you like it or not. So you are indirectly calling repr. Does that answer your question?
I think so, yes.
Perfect.
It's called when you make sphere a string.
Yes, exactly. And when you make it a string, and a string, and print turns it to a string, which calls repr and blah blah blah.
Okay, totally makes sense.
There you go. Awesome. Good question. Other questions about what we just saw. Now, if you're thinking, when should I write a repr? Well, if you're ever going to need to print out the thing that you're creating, often you are going to write it. Usually, the magic methods, your constructor, and your EQ and your repr, those are you're almost always going to implement those things. They're pretty handy magic methods that come up a lot. And if we were to go back to the circle version, if you were to go the circle class, this is how we would write it for the circle class, right? The circle and then radius, whatever. And then finally, if I wanted to test this class, right? So not just the repr, but everything in this class, well, here's what I would do, right? I'd create a sphere object, I'd verify all its attributes, call all those with methods in various cases, check the equality, check the toString, but of course you're going to want to check multiple cases, so here's another sphere, yada, yada, yada. Now, you might feel, though, that okay, these tests are getting kind of hairy, right? It is what it is. Unfortunately, we are hitting a bit of the limit of the usefulness of our assert tests. Our assert tests were really good when testing a function, right? But here, yeah, we're testing functions methods. We're testing methods, but really we're testing the methods in order to test the correctness of the whole class. And testing a method may have required some setup code, like creating an instance, and then maybe checking each method under different conditions. It's getting kind of hairy, right? But more on that shortly. Any questions about the sphere so far? All right. Now, more object stuff. But now, we're going to kind of shift a little bit of the focus to interacting objects. I want to be clear. In the previous example, we did have interacting objects by virtue of equals, right? How we had one object getting a reference to an instance of another object, and they were interacting, right? And same with like the overlaps, right? Or distance between centers. Like those, they were interacting objects, right? But the focus of that particular topic was more about like the additional methods, right? And we did see some interacting objects, where this one's now shifting to, look, it's just going to reinforce everything we've learned so far, but it's going to kind of show how we can like cascade interacting objects. And if you don't know what I mean, you'll see in one moment. All right. Oh, and I should also say, all of these examples I'm showing you, I don't really want to use the word contrived because that sounds as if it's not valuable and it's like a silly example. No, it's not a silly example, it's a fine example. But I don't want to give the wrong impression that what I'm showing you is to suggest that this is like the correct way, like the correct design decision. All I'm doing is showing you an alternative design of the sphere class, okay? It's not to say that this is superior. There's pros and cons to this sphere class that we're going to write here versus the sphere class that we just wrote. We're going to see another version of the sphere class. It's a little bit different. It's the same, but different. You'll see. Okay. So, I could argue that we could improve the design of the sphere class because if you think about it, the sphere object had 4 attributes, an x, y, z, and a radius. But look, you know, the x, y, z, what was that? Well, that was a point in 3D space. So, what if we made a point 3D object? Okay, so we could define a point in 3-dimensional space with an object. And the sphere has a point and a radius. Now the point has an x, y, z. So what I'm saying here is the sphere class will have its radius, and instead of having like directly the attributes x, y, z, it'll have a reference to another object called a point. And that point has an x, y, z. Then with this design, like you'll notice that some of the functionality in the sphere class was really about like points in space. Like what's the distance between centers? Well, really what I wanted to know was what's the distance between these 2 points. So we could kind of offload that functionality to this Point3D class. And plus, like what's stopping us from creating like a cube class, right? If we made a cube class, the cube class could also make use of the Point3D object too, right? Like it wouldn't just be needed for a sphere. Suddenly we're now creating this new object that has like more use cases, for example. Any questions about that idea? We're going to flesh it out, don't get me wrong. But any questions about that high-level idea at this stage? Okay, so there's nothing wrong with the sphere implementation we just did. Like I was saying, there's nothing wrong with it. I'm really just showing you this as an alternative implementation. What makes sense to do depends on what you want to do with your code. So, okay. So we're going to make a sphere class. It's going to be similar to the other one, and it's going to allow us to write methods at a higher level of abstraction since we can deal with the Point3D object. You'll see in a moment. And if we wanted to make other 3-dimensional shapes, we can make use of the Point3D. It allows us to abstract and delegate functionality to other classes. And it'll also help with testing because then we can kind of like isolate the testing to do with like the points in 3-dimensional space versus like the spheres. You'll see. First, in order to make to do this, okay, a sphere class is great. We've got like our general idea of our sphere class, but in order to do it this new way with a Point3D object, we need to define a Point3D class, right? So what does a Point3D class need? Well, it's going to need an x, y, z coordinate. So, all right, we could just make a constructor with an x, y, z coordinate. Here. I'm going to get rid of all of this, delete there. There, that's it. I'm creating a Point3D class, x, y, z, x, y, z. Boom, that's it. Very simple stuff. And what methods are we going to want? Well, okay, we're going to want methods for, I mean, we can add whatever methods we want, right? Now, I've got my sphere hat on. What did we just implement in the sphere class? So what could we do? Well, I might want a method for measuring the distance between two Point3Ds. I might want to know if these two Point3Ds are equal. I might want to generate a human readable version of a Point3D, right? So, okay, we can, I mean, really that's just like, we've got a constructor. Looks like I'm going to want a repper, I'm going to want an EQ, but I'm also going to want like the distance, right? A method to measure the distance between 2 points in 3D space. Great. So here we go with our constructor. And now for our methods. Okay, distance from point. Copy this over. Oops. There. This right here, if you were to go look at the sphere class, yeah, this is just basically taken from the sphere class. There's nothing sophisticated going on. This is just Euclidean distance in three-dimensional space. Okay, that's all we got going on. The difference in their x's squared, y squared, and z squared, square rooted. All right, cool. All right, any questions about that? Very simple function, our method. So now, let's just make sure we're not crazy. If I were to say like point A equals Point3D, and then B equals 3D, 0, 0, 0, and then, no, what? 1, 2, 3, there. I'm creating 3 different points. 2 are clearly equal. Here, let me zoom in. And is the lighting fine? It feels like it's kind of washed out over there. Let's lower the light. That's better. That's fine. There. All right. So now let's just do some sanity checks. Print. So point A dot distance from point B. What should the distance be? Oh, come on. Is no one paying attention? What should the distance be between point A and point B? 0. Good. Okay. Whew. All right. Awesome. I mean, we could do distance from itself. Fine. And should it matter if I do point A, point B? No, because the distance from me to you is the same as you to me, right? It doesn't matter. Cool. There we go. And just as a reminder, right? Self inside this class, self would refer to that instance is x. And the other is, well, the other one I'm comparing it to. So when calling it down here like this, it would be point B, the thing that references point B, the thing that point B references, self references the same thing. They're the same. And other would be point A. But if I go down here and I flip it, now self is point A and other is point B. Doesn't really matter, but it's important to know what's going on.
So when you have two objects with the same attributes, like point A and point B, are they two separate objects, or are they a reference to each other?
Well, let's check that right now, because that's literally where we're going. So that's great. If I were to say, because remember, point A, what is the default behavior of equals equals? Did I define EQ for this yet? No. So, point A, point B. Okay? We can look at this as humans and say, yes, they're clearly equal. Now, by making that statement, I'm already like applying some like Well, what does it mean for them to be equal? Well, their attributes are the same. How the hell does Python know that? It doesn't. Sure, you might say it should be obvious, but Python, look, it's probably good if Python doesn't make assumptions, right? You better be clear about what you want. So, of course they're equal. False. All right? Why false? Because the default behavior for EQ is this. Is. And who here remember, what does is do? Checks if they're aliases. Checks if these are two references that reference literally the exact same thing. False. Now, well, yeah, clearly that's true, right? And you might be like, well, how come this is saying it's equal? Well, that's just by virtue of it also they're literally the same thing. And in fact, like check this out here, and let's do like point D equals point A. There. Now they are quite clearly aliases, right? And like check this out. We haven't written the repr yet. Okay, so watch this. This is pretty neat. Point A, print point B, point C, so, A, OX, 7C, blah, 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 blah. Let's just go down here. C740. 4710, they're like different, right? B410, I mean, the 10s, I mean, but these are different numbers. And remember, I know these don't look like numbers, they're numbers. It's complicated. But then here we have C740. Oh my God, it's the same thing. So the two aliases, when you print out the object, it's the same thing. So they clearly are in the same location, because this is like their memory address, right? It's complicated, but you can think of it like that. So yeah, there we could clearly see, like, oh, they literally are the same thing. If these numbers match, it's like saying, like, go to the house at this address. Well, if you get to that address, there it is, right? All right, great. So yeah, okay, cool. So yeah, to answer your question, no, it won't know until we tell it. I mean, it knows, in a sense, it knows, because whether I write the EQ or not, there is an EQ in this class. It sneaks one in for you. You'll never see it, though. The same is true, and I showed you this before, but just to restate it, the same is true for init. If you don't write init, it sneaks one in for you. It doesn't do anything, but it allows you to, like, instantiate an instance of the object. And I'll show you. Let me just prove that to you. If I go down here, class, some class, pass. Pass is just a keyword that says Python, based on how it parses, if there's ever a colon, there needs to be an indent. There needs to be something on that line of code. Pass is a line of code that says, like, shut up. That's it. That's really it. If I go down here, I can say A equals some class. Print A. Boom. I can make it. There's no init. So you can say, well, how does it know how to, like, what does it do? Well, if I don't write one, it sneaks one in for you that really is just going to be this. There. That's what it's doing. That's like what it would look like. All right? But not helpful, we override it. All right, cool. So going back here, let's define equality. So the default, oops. Point3D, and that'll return a bool. The default will be there. Like, that's the default. I didn't, like, look, I wrote it. You'll never see it, but if you don't write it, this is like what it's going to include. All right? You'll never see it, but it's there. But instead, what we're going to do is say like, okay, well, first, if is instance other point 3D. So if other is in fact a point 3D, do I need to check if self is a point 3D? No, because if you're asking an instance of a point 3D, it's going to be a point 3D. It's not possible for it not to be. I mean, you could add that code, but you can't be like, hey, point 3D object. Are you a point 3D object? Like, that's foolish, right? Like, you couldn't, right? So if the other is a point 3D, now we can actually check. Okay, return if self dot x equals other dot x and self dot y equals other dot y and self dot z equals other dot z. Oop. There. Now, with EQ defined, let's get rid of this. I can now say now it's true. Because I told Python, yeah, okay, that's great and all, but this is what I want you to check if they're equal. Okay? And remember, you can do this. You can, if you really wanted to, you can call EQ like this. Don't ever call it like that. That's ridiculous. The whole point of these methods is like the syntactic sugar and whatnot. If you want to call it, you do it the way we are always checking equality between things, with equals equals, okay? This means that. That's what that means, okay? These mean the same thing, but you don't write that. That's gross, right? Remember, the Python police will get you. Guido himself, whose picture is over there somewhere. There, look how happy he is. That's the look on his face. He's over there. He's over there. Guido, he made it. He made Python. He's the guy. Anyways, we defined EQ. Any questions about this? EQ, everything's good? This really, at this point, this is review. And now, okay, yeah, there's the EQ. And now repr, let's get repr. We'll make our repr look like this. There. Now, if I go back, actually, no. There. There. Cool, right? Now with that new repr, it formats it a lot nicer, right? So if you wanted to print out the instance, you get something a little bit more valuable to me as a human. I really just want to emphasize, though, that what your repr is, I mean, really doesn't matter. Right? If I do this, okay, that's, whoops, there, that's what it's going to do, right? Not very helpful, but that's all it's doing. And remember, repr does not print anything out. It returns a string. And in spite of me yelling about this, there's probably a good 20% of you that's going to blow it on the test. Break the streak. I don't want anyone this year to blow it. Returns a string. It doesn't print anything. If your repr prints something out, I'm going to lose my mind. I'm going to get so mad. You'll disappoint me. Okay, any questions about the repr? Again, this is review, so if you have a question, now's the time. Yeah?
Sorry, can you just, what does the repr do just again?
The repr is the definition of, here is a string representation of this object. So in this particular case, here is a string representation of a point 3D. I want it to look like this. I could make it look like this. Oops. That's foolish. That's useful. This is a common pattern if you don't have anything else in mind. I mean, look, someone might be like, no, look, it's clearly a point 3D. We don't even need to say, then, okay, sure, fine. There's an interesting argument like that, right? Like, consider it as like how you would write like a point in three-dimensional Euclidean space, x, y, z, right? Okay, yeah, sure, fine. You could do it like that if you really wanted. It's up to you, the programmer. So basically now, with the repr set, I can print it out. It looks nice. Without the repr, I print it out, we get the. That's the default repr. Thanks, right? But a lot more helpful.
It basically just tells the program how you want it represented.
Exactly that. That's exactly what it is. Yep. Yeah. Other questions? Because this was review. So if anything of the review went like, wait, what? Ask now. Now's the perfect time to ask. So confused. Why is only half the class here? Is the class too easy? Because the test results would suggest otherwise. I don't get it. Does anyone know, is there an event? People say they watch the videos, but there's like 2 views. It's like, well, I don't think that's true. And of those 2, they watch like 2 minutes. So, I don't know. All right, so that's the point 3D. How would we test it? Here's some testing. Great. Cool. Again, you might notice, these are getting kind of hairy, but it is what it is. This is what we have to deal with the assert tests. We are hitting the limit of the usefulness, if we have not already past the limit of the usefulness of the assert tests. Okay, now with the Point3D class, now with the Point3D class done, we can go back and refactor our sphere class. And refactor is just a fancy word to say, okay, look, there it is, it's fine, but let's rewrite it in a way that we're happy with, right? That's refactoring. And, okay, actually, really before I do that, I'm going to ask it one more time. And I really want to emphasize, if you have a question, probably half of the people in the room have the exact same question as you. But the problem is, you're all sitting there going, that's a stupid question. I must be so stupid. I don't know what it is, right? But you're all thinking it. So just be the brave one and ask the question. This is a simple object, Point3D. It was review. That is not to suggest that I expect you to know this all 100%. I'm reviewing it to reinforce what we've seen. So if at this stage anything is unclear, defining the class, what's the constructor, what's the attributes, the methods, other, self, EQ, repr, any questions about any of that at all, ask now. Okay, all right. That's fantastic then. Okay, so let's get back to the sphere class. Think about what is it going to take to do this refactor? Actually, you know what? We're going to do a lecture activity. Student class. Yes, absolutely. Student number. There. That's what I want you to do. Let's make it. Yeah. Oh. It has to be into me on or before, no, strictly before 20 after. Remember, you can chat and whatnot, by all means. I guess I'll stop the recording.